Yes. Yeah, good afternoon all. Yes, before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes.
Yes.
And thank you. Just a second. So myself, I'm Vijay. I hold 20 plus years of experience in different technologies, starting from big data, Hadoop, Spark by Spark, this Azure data engineer and GCP data engineer. So as part of today's demo, I'll be covering the following things like what is Google Cloud Platform, what is GCP, and data engineer as compared with the traditional ETL developer. Data engineer as compared with the traditional ETL developer. Who is a GCP data engineer? Who is a GCP data engineer? And what does a GCP data engineer do? GCP data engineer roles and responsibilities, and various GCP data engineering products and services. Job market of GCP. So this is what I'll be discussing, right? Yes. So we have got many cloud platforms. We have got various cloud providers. If I talk various cloud providers, right? So if I'm talking GCP, so various cloud providers, we have got like AWS, Azure, sorry, AWS, Azure, GCP, Oracle Cloud, Salesforce, VMware, Liquid Web, Alibaba Cloud, like even we have got like Rackspace, Digital Ocean, right? So in this way, we have got many cloud providers, cloud service providers in this. among all this, most companies are preferring the first three, right? GCP, Azure, and AWS. They are preferring GCP, Azure, and AWS. In that, GCP is mostly used today, and GCP is one of the fast. So growth is increasing at rapid speed. We can see GCP growth is increasing it rapidly. Companies are migrating towards GCP. Companies are migrating towards GCP. Right. See, one second. What we do in GCP, I'll come back. Okay. GCP uses GCP uses some infrastructure for the users for storing. See, generally Google, if I talk about the Google, it uses some infrastructure for the users. See, you are storing YouTube videos, Gmail messages, and Google search engine data, right? How the Google is using the same infrastructure. In the same way, GCP is using the same infrastructure for storing data and for computation. Here in GCP, we store data, we read or retrieve data, we can perform data analysis, can perform data analytics. We see high availability of data. See, if data is what do you mean by high availability? If data is stored in different places, if one server is down, we get the data from other server. This is called high availability. Here data is safe and secure, just like Gmail. Here data is safe and secure like Gmail. It is easy to scale. And here, if we talk about AWS, Azure, and GCP, if you talk about this AWS, Azure, and GCP, you may ask why to choose GCP only when we got Azure and AWS. Why to choose GCP means there are many reasons. GCP the fastest or the biggest network in the world. It is the fastest or the biggest network in the world. See, Google, see this Google has got data centers. Google has got a data centers throughout the world. It uses high-end virtual machines. It uses high-end virtual machines. And also like petabyte bandwidth, high performance, even separation of compute and storage, even whatever the computations and the storage means each individual virtual machine will have its own separate RAM and data storage. Even pricing also like flexible pricing. Pricing, if I talk flexible pricing, right? Yes. We check. If you see the previous one, separation of compute and storage, each cluster will have many systems. Each cluster will have a number of nodes. The number of nodes we can store data, the data stored in single node. If it gets crashed, then the data is lost. But in GCP, if one copy is stored in one machine, other copies are stored in different machines, so that from different data centers we can retrieve the data. I was talking about pricing. GCP has flexible pricing as compared with AWS as well. GCP has flexible pricing as compared with AWS as well. Discounted price for long running workloads. Discounted price for long running workloads. 10 years or 15 years or 5 years or 10 years, 15 years if we are taking discounted price for long running workloads. In few cases, okay, we see the GCP prices are high, but overall GCP prices are very flexible. And even if you talk like customization, wide range of customizations for any GCP service instances. In cloud, we can create many instances. For that instance, we can customize depending on the requirement. We can have only 1 petabyte storage, or if you talk different softwares we need to install, right? Yes. So customization is possible in GCP. If I talk like scalability, easy to scale means what do you mean by scalability? Increasing or decreasing the capacity. You can take for 1 year and it got filled. You need to increase, means you need to scale. In Azure or AWS, they are not that much flexible for the scalability, but here it is scalable. Live migrations. Supports live migrations for virtual machines, GCP, but in Azure and AWS, they doesn't support live migration. Means whatever existing systems you got, whatever existing systems used, for example, you have got data in Hadoop, you can lively migrate to GCP without impacting the existing data. And also big data or ML, we can get inbuilt and pre-trained machine learning and AI APIs in GCP. Inbuilt or predefined machine learning or AI APIs in GCP. Free trials, we got free trials. Some services are free from lifetime. Some services are free for 12 months. Some services are free for 3 months. And customer systems migration. The existing data migrations to GCP, for example, from Twitter, from Vodafone, from HSBC, from New York Times, from Coca-Cola, from Spotify, from various things migration. Customer systems migration. Okay. The talk like data engineer versus ETL developer. So these are the what I was talking about, why we need to go for GCP, why to choose GCP. These are the various reasons, right? And And if you talk about a data engineer versus ETL developer, a traditional ETL developer, see, data engineer has got lot of roles. If you go back like 10 to 15 years back, there is no concept of data engineer. What ETL developer, right? But he used to work most of the time. He was working with structured data only. But today's data engineer, if you talk, he should deal with data. Today's world is flooded with the data. Total world is flooded with the data. So so everything deals with the data. Data has got experience. Data has got future reference. Using data, we perform different things, right? Data has got experience. Data has got. See, data engineer deals with the data. That is data management. Data engineer deals with the data management. That is data storage and data processing. Data storage and data processing. But a data scientist he won't deal with the data storage and processing. He deals with the data analysis, data predictions, data classifications, data clusterings, data recommendations. So data scientists do all this. But a data analyst is just going to summarize the data of the past and visualizing the data. So data engineer should be able to handle all varieties of data. To handle all varieties of data, it should work with structured, semi-structured, unstructured data. Should work with streaming data. Should work with NoSQL data. Should work with all formats of data. It should work with all varieties of data, all formats. All varieties means structured, semi-structured, and unstructured. All formats of data means like all types of files, Excel files, CSV files, JSON files, all types of file formats in it to work. See, if you talk like data engineering involves handling the data. Data engineering involves handling the data, ingesting data, or extracting data, or storing the data, filtering the data, transforming the data, or processing the data, merging the data, or sorting, or grouping, or analyzing the data. See, he is going to pull the data from different sources. Data engineer is going to pull the data from different sources, from databases, from IoT systems, from apps. Yes. And those store it, they process it, and finally they are going to dump into different target. It also data engineering also involves how to extract data. What are the sources from where data has to be extracted? What are the sources of the data? What is the format of the data? They need to be transformed as per that. How to process the data, and what is the destination of the data? What is the destination of the data? See, from different databases, IoT and applications, they need to extract data, store it, and process it, and load it into the target. A data engineer designs and maintains an entire organization's data infrastructure. He also includes complex data pipelines. You need to deal with the big data technologies. Also, while it focuses, so preparing data for analysis into data warehouse. Data engineer has got a broader prospect as compared with ETL developer. ETL developer has got a specialized role. Data engineer I said it maintains the overall data infrastructure, data pipelines, and databases. Responsibilities of data engineer like should be handling with big data technologies, cloud services, data preparation for machine learning, and implementing both batch and real-time data solutions. Batch and real-time data solutions. You should be very much proficient in multiple languages. You should be proficient in multiple programming languages. Yes, like Python. A GCP data engineer, if you talk, what a GCP data engineer? ensures data quality, is going to ensure the data quality. Data storage and processing, just what I was talking about, data management, data storage and processing optimizations. Collaborating with the data scientists and analysts, and we need to prepare the data as per the requirement. And also for the business teams, you need to collaborate with the business team to know the data requirement. You need to keep in mind while dealing with the data in the hand. Monitoring data infrastructure, implementing ETL and data security. All this is that is the work of GCP data engineer. So data engineer, it's a process of transforming the raw data into useful format, which is further it is analyzed by the other teams. See, as I said, cleansing, organizing, manipulating, using pipelines are some of the key responsibilities of data engineer. So we'll be working on applying data engineering principles on the Google Cloud platform. As a Google Cloud engineer, you'll also have to collaborate with other engineers like marketing teams, product engineers to enhance the structure optimization accordingly. Okay, that is what. But if I talk about in our course data engineering, right? GCP data engineer. So what are the key products or services that we work with? What are the key products or services we are going to work with? Yes, check with this. GCP, various GCP products or services. GCP cloud storage for storing the data. BigQuery, Google BigQuery. Just a second. Just a second. Someone facing problem with this. Sorry. Cloud storage for storing the data. BigQuery for fast querying, for storage, for analysis of large data sets. We work with Dataproc for big data processing and analytics. Databricks also for PySpark processing in GCP. Data flow for streaming and batch data processing. Streaming data means data which keeps on generating, data which keeps on incrementing. Such data we call as stream data. And batch data processing or batch processing means, see, generally online processing, batch processing. Online processing means user interactive applications. User gives the input. But here, batch applications, user non-interactive applications. Millions and trillions of records will be dealing with. Cloud Composer or Apache Airflow for automating and monitoring big data pipelines. And we have got pub or sub, messaging or data ingestions, for messaging or data ingestions. Okay, if you see in GCP, the total GCP cloud platform, it will be categorized into 4 categories. Just check it. GCP, the total GCP cloud platform, the products will be categorized into 4. One is compute, one is storage, one is big data, and machine learning. Again, in compute, if you see in compute, app engine, compute engine, container engine, cloud run. Understand this. App engine for building scalable web applications, compute engine for large scale workloads, container engine for running Docker containers, Cloud Run is a managed compute platform on Google's infrastructure, right? It's fully managed compute platform for deploying, scaling, containerized and applications quickly and securely. And also we see cloud functions elsewhere, cloud functions. Cloud functions, a serverless platform. It is a serverless platform for building event-based services. For event-based services, yes. So here in the case of compute engine, right? In the case of compute engine, we run virtual machines. We launch large compute clusters, large compute clusters. You can run thousands of virtual CPUs. And here, if you talk like in GCP app engine, so these things will be understanding slowly. Uh, Let's application developers build web and mobile applications in any programming languages. And if I come to the storage and this databases, storages, right, and database services, like object storage, relational storage, non-relational, NoSQL, or data warehouse. We talk about that object, cloud storage, we say like kind of object data storage, images, media, backups, all these things. And if we come to the relational storage or relational, like we have got Cloud SQL, Google Cloud SQL, and Cloud Spanner. Good for web frameworks. Cloud Spanner, right? Cloud Spanner for RDBMS. Non-relational or NoSQL. Non-relational means Cloud Firestore for hierarchical mobile and web. Bigtable. Forgot Bigtable for heavy read and write events. Heavy reads and writes. And for data warehouse kind of operations, we have got a BigQuery for enterprise data warehouse, analytics and dashboards. See this Cloud SQL, right? Simply we can migrate traditional databases like SQL Server, MySQL, Postgres. Cloud Firestore can handle document type storage, non-relational, NoSQL. Document storage means we talk about NoSQL, we got key value DB, document DB, columnar DB, and graph DB. In that Cloud Firestore, similar to MongoDB, similar to MongoDB. MongoDB is also document DB. It's a kind of document store. And even this Bigtable supports like key value pair, BigQuery for data warehouse and for analytics requirements. Okay. GCS Google Cloud Storage just doesn't want to enter into the technicals as of now, but just for storing and managing unstructured data like files, images, and videos. Data is stored as objects within the containers called buckets. Objects means immutable piece of data such as file or any format. Okay. If I come to this big data, Dataproc, Dataflow, Databricks, PubSub, BigQuery. So mainly for this big data, it brought a revolution in this distributed computation, distributed processing. So big data, it brought a revolution in this that is distributed computing or like parallel processing, right? Yes. say like Dataproc, Databricks for PySpark, especially like PySpark processing. We see like PySpark, very high speed processing technology, very high speed processing technology, right? Which is used for huge data processing, very high speed. I'm saying very high speed processing execution model. If you see the speed of this, if you see the speed of many tests were done already. Yahoo Yahoo has taken a table of 1024 columns. Yahoo has taken a table of 1024 columns. Task sorting based on 16 columns. Sorting based on 16 columns. So time taken by different things. Time taken by, see for this, it has taken a table of 100 TB, 100 TB consisting of 1024 columns, sorting based on 16 columns. Time taken by Oracle has taken around 3.5 days to process. It has taken around 3.5 days to process. MySQL, it has taken around 6 days to process. Teradata is there, a specialized database used for data warehouse. It has just taken 4.5 hours. Netija, another specialized database used for data warehouse. It has just taken 3 hours. Finally, there is a big data Hadoop. It has just taken 3.4 minutes. It has taken. Hadoop is a very high speed processing execution model. But if we talk like PySpark, 100 times faster, 100 times faster than Hadoop. You see, Hadoop has taken 3.4 minutes. What will be the speed of Spark, where it is 100 times faster than Hadoop? It's faster than Hadoop, or PySpark is faster, 100 times faster than. Hundred times faster than normal disk processing. Normal disk processing. That's why very high speed for this PySpark processing. For all this we use like Databricks for big data, for all these things, right? Yes. So we have, okay. I doesn't want to enter into the technicals as of now. Later we discuss about those. Yes. BigQuery is also a serverless, high scalable enterprise data warehouse on this GCP. It enables super fast SQL queries, petabytes of data. It includes serverless architecture, scalable, cost effective, SQL based analytics, built in machine learning. You can see BigQuery, Omni, you can see. Yeah. Even BigQuery integrates with Google Cloud's Identity Access, IAM. And if we talk about this data proc, Spark and Hadoop service that lets you take advantage of open source data tools for batch processing, for kind of batch processing, querying, streaming, information learning, right? This data proc and talk. It helps you to creating clusters, manage them easily, right? Okay. So here we'll be building data pipelines to get data from multiple sources into data lakes. We build data lakes or data warehouses. We walk through this data engineering pipelines. It includes the various services I was talking about. Okay, now machine learning. In machine learning, like vision API, speech API, translate API, and machine learning. So even working with GCP subscription, it is providing free subscription. GCP free subscription like $300 credits will be added freely to your account. Means around 26,000 rupees credits will be added to your account. Means which you need to use within 3 months. Within 3 months. After 3 months, again, if you want to create one more account, you can create one more account. So how to interact with GCP services, the other things I'll be discussing. But just it is an overview today. I want to see, you can just check with the course content once. 1 second. Just give me a second. I'll forward you this. 1 second. Check with this course content, right? GCP data engineering. Even you can see in the Zoom chart, right? In the Zoom chart, the admin team has forwarded a big message about this course content details and their contact details, various other details they have provided. You can check it if you got any concerns. So starting with module 1, GCP data engineering fundamentals, module 2, Google Cloud Storage. So in module 3, Cloud SQL setting up database. Module 4, BigQuery for building the data warehouse. The module 5, Dataproc, big data processing. Databricks, PySpark processing. Dataflow, Apache Beam development. And Google Cloud Composer and data fusion, data integration service, dbt, airflow, and terraform, right? Okay, so introduction to the Google Cloud Platform, overview of this cloud platform, IAM, identity and access management, resource hierarchy, billing and cost management. And getting started with GCP, signing for GCP account, creating new account, dummy account, means with Gmail ID, without Gmail ID, and storage and databases in GCP. Google, okay, Google Cloud Storage, GCS, setting up a data lake using GCS. Yes, you can check with this, right? Yes, all this. Cloud SQL, setting up Postgres database using Cloud SQL, and the data ingestions and integrations, data processing and transformations, data warehousing and analytics like BigQuery. BigQuery for building data warehouse, you can check with this food operations, all this. Big data processing, getting starting with GCP Dataproc, ELT pipelines using Dataproc, and over Databricks, PySpark processing in GCP, ELT pipelines using Databricks, integration of Spark on Databrick and BigQuery, Dataflow, Apache Beam development, Cloud PubBar Sub, and Cloud Composer for data pipeline orchestrations, everything, Data Fusion, Cloud Functions, Terraform, and pipelines using dbt, airflow, and BigQuery. Yes, machine learning in GCP, security monitoring and governance, and real-time GCP data engineering scenarios like BigQuery, BigQuery, Dataplex, GCS, right? These things. Okay, in brief, in depth, we'll be discussing about it, each and every component, right? 1 second. Gautam. Okay, along with this course, right? Yes. So 1 second, I'm coming to it, Gautam, right? Yes. So and after one second. The offerings from my side, each and every session video you'll be getting the record. Each and every session will be recorded. You will be getting the recorded video of the session even if you are absent for a particular day, right? It's a weekend batch, Saturday for 2 hours, Sunday for 2 hours. And you will be getting the soft copy of the class notes, assignments and tasks to work, a WhatsApp group, and interview questions, around 200 questions, and live interactive hands-on sessions. Even if you want to do the tasks practicals along with me parallelly, you can do it. So these are the offerings from my side: video, soft copy, assignments, tasks, a WhatsApp group where you can have direct interaction with me. I said. Apart from this, DurgaSoft is providing a Unix Linux shell scripting videos, around 120 videos of Mr. Durga, and MySQL videos, around 35 videos, and also Python videos. So the prerequisites you asked, right? Just basic Python, basic SQL, right? Basic Linux knowledge is required. Even still, otherwise you can also just go to the videos that is provided. Anyhow, I will be providing, before I go with the practical part of for this where Python is required, I'll be just providing you the, I'll provide you the syntaxes of this Python. But still you are given with the around 7,000 rupees video access will be given freely once you get enrolled for this course. Means you can just enroll for the course, and meanwhile you can just go to the videos of Python and this Unix and this MySQL, right? So tomorrow also will be, we can people can attend the session same time at 3 o'clock to see more discussion, right? From tomorrow we'll be starting with the actual things. So timings of this batch, I'll make it clear about the timings of this batch. Timing of the batch will be 4 p.m. to 6 p.m. 2 hours on Saturday, 2 hours on Sunday. Sometimes I'll be extending it. So but meanwhile the demos it goes at 3 p.m. but later the regular sessions will be from 4 p.m. to 6 p.m., right? And also the job market of this GCP, right? Becoming a cloud data engineer, now it is the correct time. So cloud computing and data engineering skills are increasingly in demand today. Or more companies are getting digitalizing their solutions. Okay. So if you see in 2024-25, if you see the year of increased demand for data engineering and artificial intelligence and this cloud technologies, right? So the cloud professional data engineers are currently, they're in high demand and high requirement for these people, right? So the same way, you need to have good technical skills for performing this as part of the course. Step by step, I'll be showing you everything. Okay. And also, if you see the pay scales of data engineers, they have got highest average salary as closely as data scientists. Even the two highest paying jobs like data engineers and data scientists. So pursuing a data engineer, right, will never let you down. Okay. So many companies like Facebook, Intel, Microsoft, they are interested in hiring these data engineers at a great salary packages. Even companies like Google, Apple, Cognizant, Walmart, all they are offering high paying jobs to this data engineers, right? So that are the offerings from my side. That is the course content, and this is the offering from the DURGASOFT they'll provide. Once you get enrolled, you can get this video access and go through those. Yes. Any other queries you got, right? Apart from this. Okay. Fine. Tomorrow also at 3 p.m. people can attend to see more discussion on this. Okay. Any other queries? Yes. Okay. So if I'm done with the queries, if there are no other queries, I will sign off for now. Meet you tomorrow, same time, 3 p.m. with same link. Thank you all for your time. Thank you.